Hello everyone, welcome to Basics e-learning.
In this video, I am going to explain basic operations performed on signals. The basic signal operations are of two types. Operations performed on dependent variables and operations performed on independent variables. Generally, the signal is represented either as x of t or x of n. X of t represents continuous time signal, whereas x of n represents discrete time signal. From the definition of signal, signal is the information where it depends upon one or more independent variables. So here x of t means t is your independent variable and x is the signal that is depending on independent variable t. So x is the dependent variable. Remember, t is your independent variable. So if you are performing on the time scale here, then any operations or any modifications if you want to do on the time scale, then you have to use these operations of independent variables. If you want to perform any operation wholly on the amplitude of the signal, then you have to go with the operations on independent variables. So here is the list here. Operations performed on independent variables are amplitude scaling, addition, multiplication, differentiation and integration. Whereas the operations performed on dependent variable, that means on the time scale here. See, let me write here. This is on the time scale. Operation performed on the time scale. This is on the signal itself. So the independent variable operations are time scaling, time shifting, time reversal. Now I am going to explain each and every operation with example. Let us start discussing about operations performed on dependent variables. As I am talking about dependent variable, that means we are performing operations on x wholly, that is amplitude. So the first one here is amplitude scaling. If the signal is x of t and you are multiplying the signal with some constant c, the resulting signal is y of t. This type of operation we call it as amplitude scaling. Here c is called a scaling factor. So the c can be any constant, any number. So let us consider a signal, base signal here. Let us say it as x of t. Some sinusoidal signal they are taking with amplitude peak to peak as 1 to -1 here, right? Now, suppose if the constant c is equal to 0.5, let us say the constant c is equal to 0.5. The x of t signal amplitude is from -1 to +1, right? So now, if it is 0.5, then the amplitude of x of t is multiplied with 0.5. That is, after performing the operation, then it will become -0.5 to 0.5. So let us consider the second picture. If the constant c is 0.5, that is the scaling factor is 0.5, the amplitude is reduced to 0.5 to -0.5. Just multiply the scaling factor with the peak to peak amplitude of your given signal. Suppose say, if the scaling factor is 1.5, that is you have to multiply the maximum amplitude and minimum amplitude with that scaling factor 1.5, then the signal becomes like this as in the figure C here. So the maximum amplitude is plus 1.5 and the minimum amplitude here is minus 1.5. So such type of operation we call it as amplitude scaling. This type of operation is practically used in amplifiers. And the second operation is addition here. Let us consider two signals x1 of t and x2 of t. Perform normal addition, then we'll get the resultant signal as y of t. Now we'll see how to add two signals with one example here. Let us consider x1 of t. This some signal it is given. x2 of t is some other signal. If you add these two signals, how we'll get the third signal, we'll see. So from the first x1 of t, I have it t is equal to -2. My amplitude of x1 is 0, right? 0. At -1, I have amplitude at t is equal to -1. Amplitude of x1 is 2. Similarly, at t is equal to 0, amplitude of x1 is 2. At t is equal to 1, amplitude of x1 is 3. At t is equal to 0, we have two signals here. It is showing, right? So 2 and 3, both it is showing. Let us write like that. Then at t is equal to 2, again I have amplitude 3. For x2, the second signal at the same time scales, let us write. At t is equal to minus 2, I have the amplitude as 2. At t is equal to minus 1, again 2, 0, I have again 2. At t is equal to 1, I have 1, and t is equal to 2, the amplitude is 0. Right. Now, see, just try to add the amplitudes to get y of t. That is x1 plus x2. At t is equal to minus 2, you have 0 amplitude here. Here you have 2. So 0 plus 2 is 2. So mark 2 here. At t is equal to minus 2, you have amplitude as 2. Similarly, at t is equal to minus 1, 2 and 2, you have 4. At t is equal to minus 1, the amplitude is 4 here. I am just adding both the amplitudes to form the new signal. Next, at t is equal to 0, you have 2 and 3 both here. But here at x2, you have only 2. So 2 plus 2 is 4, you have a cut here. Then 2 plus 3 is 5. Mark both the points. So here 4 and 5. Next one is you have 2 plus 3 is 4 and 3 plus 0 is 3. So mark at t is equal to 1, I have amplitude 4. At t is equal to 2, I have amplitude 3. Now join all the points, right? So join all the points here to form the signal. So this is how I can do the addition process of two signals. And the third operation here is multiplication. Let us see how to multiply two signals and what is the resultant signal. I'll explain with some example how to draw the resultant of a signal when two signals are multiplied. So consider the signal x1 of t here. So this x1 of t is extended from minus 3 to 3. Whereas x2 of t is extended from minus 5 to 5. Here we have to multiply each and every amplitude of x1 and x2 at each time interval. That is at minus 5, here at minus 5. That is the amplitude of x1 at minus 5 is 0. Amplitude of x2 at minus 5 is 0. So that those two amplitudes you have to multiply. That will be the amplitude of the resultant signal. So let us write the table so that you can understand in a better way. So at time x1 and x2, the resultant. I am going to mark the amplitudes. Here the signal that is extended from minus 5 to minus 3 here is 0 for x1 of t. So I am not writing. So I will just write minus 5 to minus 3. The signal here is 0. So 0 multiplied by anything is 0 only in answer. So I am not writing here. So next you mark it from minus 2. At minus 2, that is at t is equal to minus 2, the amplitude of x1 is 1. At t is equal to minus 2, the amplitude of x2 is also equal to 1. Then at t is equal to minus 1, the amplitude of x1 is 1 and the amplitude of x2 is also equal to 1. At time t is equal to 0, the amplitude of x1 is 2, whereas the amplitude of x2 is also equal to 2. At time t is equal to 1, amplitude of x1 is 1 and the amplitude of x2 is also equal to 1. Similarly, at time t is equal to 2, I have amplitude here for x1 is 1 and x2 is also equal to 1. Carefully you mark all the amplitudes here. Then at time t is equal to 3, I have 0 at x1 and 1 for x2. Then again, no need to write 4 and 5 because anyhow the signal is not there here for x1. 0 multiplied by anything is 0. So Now I will try to multiply the amplitudes of x1 and x2 to get the amplitude of the resultant wave here. So 1 into 1, 1, again 1, 2 twos 4, 1, 1 and then 0. So let us mark these points here. At -5, -4, -3 we have 0. Then at -2 we have amplitude 1. At -1 we have amplitude 1. And at 0 we have amplitude 4. And at 1 we have amplitude 1. At 2 also 1. And then at 3 we have 0. Now mark all the points and then join all the points to get the resultant wave. So we may get a doubt whether we have to draw a straight line or a slant line. See here, check the signal. Suppose say here from -3 to -2 we have a slant line here. So that's why I am writing slant line. Then again if you have a straight line then you draw a straight line. So like this we can find out the amplitudes of the resultant signal when two signals are multiplied. Now where we are using this addition and multiplication of two signals. Suppose say if I want to add two signals with one as low frequency signal and one with high frequency signal, then we will be using frequency mixer. So such kind of frequency mixers use this type of signal addition. Similarly, as you know, in communication we are using modulator, right? So modulator is the one which combines two signals, that is the message signal and the carrier signal. The resultant modulated signal is nothing but message signal multiplied by carrier signal. In such type of operations, we are using this multiplication operation. The next operation here is differentiation. If you pass a signal x of t through differentiation operation, the resultant signal is nothing but the mathematical operation differentiation done on the signal x of t. That means, suppose say you're taking a sine wave, and if you are applying a differentiation operation on the sine wave, you will get the cosine wave. As you know, d by dt of sine is nothing but your cos. So it is nothing but a simple mathematical operation but applying it on the signals. So where do we use this differentiation operation? As you know, this is your inductor here, and let us say the current flowing is I and the voltage across the terminals be V. Then the voltage V across the inductor is given by L into di by dt, right? So in such cases, to find out the voltage across the inductor, we will be performing this differentiation operation on the signal current. And the last operation here is integration. So y of t is equal to integral minus infinity to t x of tau d tau. Let us consider a signal x of t which is nothing but a cosine signal. If you perform integration operation on the cosine signal, it will be a sine wave. So this is nothing but the reverse operation of your differentiation. Now let us see where do we use this integration operation on the signals. Suppose consider a capacitor here, and let us call the current flowing here is I of t and the voltage across the capacitor be V of t. Then the voltage across the capacitor V of t is given by 1 by C integral minus infinity to t I of tau d tau. So to calculate the voltage across the inductor, as we know this is the formula. So to find out the voltage across the conductor, we need integration operation on the current signal that is flowing through the capacitor. So in such type of calculations, we'll be using this integration operation. Now moving on to operations performed on the independent variables. The first one is here time scaling. Let us consider a signal x of t. The signal y of t is obtained by scaling the independent variable t. You know, right? So t is your independent variable and x is the dependent variable. So if you are scaling the independent variable t by a, we'll get the resultant signal as y of t. Then such type of operation we call it as a time scaling operation. Let us see what happens here. So consider a signal x of t, which is nothing but some triangular shape signal that is extended from -1 to 1 on the time scale with some amplitude 1. And now suppose if you want to scale the signal with a is equal to 2, that is y of t becomes what? X of 2t. Right? Now what happens to the signal, we'll see. In the base signal, the t is extended from -1 to 1. Right? That is the t limits are -1 to 1. Now I have to draw x of 2t. I am just scaling the signal. That is t is becoming now 2t. 2t also has the same scale -1 to 1. Observe carefully. The base signal is x of t. I am scaling the signal. I am just changing the scale of the signal to 2t. So -1 less than or equal to 2t less than or equal to t. But I have to draw it on the t scale only. I am considering t only. The 2t signal, I have to draw it on the scale t only. Now what happens? You just write it for t. That is just divide it on both the sides with 2. Then what happens? T will be less than or equal to -1 by 2 to 1 by 2 here. That is the limits of the new signal, the time scaled signal. X of 2t will be -1 by 2 to 1 by 2. See here, -1 by 2 to 1 by 2. And there is no change in the amplitude because you are doing operation only on the independent variable, which is nothing but on the time scale, not on the amplitude. Right? So I'll explain one more time here. As you are taking the scaling factor as 2, the signal becomes x of 2t, right? 2t means the same signal has to draw on the t scale. So initially the time signal is extended from -1 to 1. That is, now the new signal has also the same time limits -1 to 1. As you have to draw it on the t scale only, I am just dividing it by 2 such that I will find out the new time limits here. Similarly, suppose if you are taking a is equal to 1 by 2, then what happens? X of t by 2. New signal will be x of t by 2. What are the limits of x of t? -1 to 1. But what is our new signal? T by 2. T by 2 should have the same signal limits -1 to 1. But I need it only for t. That is, you just multiply both the sides of the inequality with 2. I'll get it -2 less than or equal to t less than or equal to 2. That is the new limits of my signal y of t extended from -2 to 2. See here, this is from -2 to 2. Amplitude will not change. Remember, amplitude will not change as I am performing operation only on the independent variable, which is nothing but by t. Now observe. If the signal, if the scaling factor A is greater than 2, the signal is compressed. Right? If the scaling factor A is greater than 1, then it is compressed. Then if it is less than 1, then it is expanded. Right? The base signal is expanded. See here. Here x of 2t means the scaling factor is greater than 1. If the scaling factor is greater than 1, the same signal is compressed. Right? If it is less than 1, that is here it is half, the same signal is expanded. Right? So how many times it is more, those many folds it will reduce here. How many times it is less, then those many times it will be multiplied on the time axis. Right? This is called time scaling. Let us see the second property here, time shifting. If the base signal is x of t and on the time scale, if you are shifting the signal, the same signal, you are shifting it on the time scale either to the left or right, that type of operation we call it as time scaling. So let us consider one example here. So this x of t, that is centered at t is equal to 0 to -1 by 2 to 1 by 2. That means on both the sides it is extended from -1 by 2 plus 0 to 1 by 2 plus 0. That is, this t is equal to 0 I am talking about. Right? Now, they are telling the signal you have to draw x of t minus 2, right? X of t minus 2 means t is centered around 2. That you have to find out like this. T minus 2 is equal to 0 means t is equal to 2. The same signal is now centered around t is equal to 2. Suppose this is the signal now here at t is equal to 0. The same signal I am just shifting it, t is equal to 2. This is 1 and this is 2. And if you shift the signal, just move the signal onto the axis, right, at centered around 2. Then what happens to these limits, right? These limits also will change now, as I have added to my 0, right, to my center value, that is 0. The same we have to add it to the upper and lower limits to get the new upper and lower limits. That is here, as my signal is now centered at t is equal to 0, the upper and lower limits will be what? Minus 1 by 2 to 1 by 2 in the original signal. As t is equal to 2, I have to add 2 to both upper and lower limits. Now what happens? 4 minus 1, 3 by 2, to 4 plus 1, 5 by 2. So the new limits are here 3 by 2 to 5 by 2. Got it? Now see, what is happening here is, suppose you're taking the base signal as x of t. Okay? And the shifting here is, suppose if you are taking b is less than 0, that is a negative number, what happens? X of t is shifted to the right by the same amount, that is b seconds. If b is greater than 0, the same signal is translated towards left by b seconds, right? So if b is less than 0, then the signal is translated towards right by b seconds. And if b is greater than 0, the same signal is shifted towards left by b seconds. Or otherwise, you can remember in this way, as the signal is here centered around t is equal to 0. Now they are talking about x of t minus 2, means t minus 2 is equal to 0, t is equal to 2. That is, you are shifting the signal towards the right, means centered at t is equal to 2. As the signal is centered at t is equal to 2 instead of t is equal to 0, that is, you're moving the signal 2 units towards the right side. So upper and lower limits are also shifted to 2 units. So you can find out the new limits in this way. Now this is the last property, reflection. Suppose x of t is the signal, its reflection will be x of minus t. Just simply replace t by minus t here, right? So this is not visible, minus t, right? So just change t by minus t. Now see, this is a continuous signal here extended from minus m to m. Now the signal will be extended from m to minus 1. Just flip it over that vertical axis. Then suppose you are given with a discrete signal like this, extended from 0 to something, right? N. Then the same signal will be extended from 0 to minus n. Just flip it over that x-axis, sorry, y-axis, right? Now, suppose if you are taking an even signal, this is important. Suppose you are taking an even signal. So what do you mean by an even signal? That is, x of t should be equal to x of minus t, right? That is, see here, suppose say this is my x of t part, this is x t, then x of minus t will be this one, right? Because this is minus t, right? So such type of signals if you are taking, this is an even signal, right? X of t is equal to x of minus t. Then the reflection of this whole signal, again if you want to reflect, suppose this is extended from 1 to minus 1. Then what happens? The same signal will be from minus 1 to 1, right? That is, your right hand side will be falling on your left hand side and your left hand side will be falling on your right hand side, right? But the signal will not change. The shape will not change. That is, for even signals, the reflected version is identical. And consider the odd signal. Odd means what? Either the first quadrant should be equal to the third quadrant or second quadrant should be equal to the fourth quadrant, right? So let us consider this odd signal here. Now, if you take the inversion, reflection of the signal, right? That is, first quadrant will go to the second quadrant, third will go to fourth here. That is only the reflection. No, I'm just flipping it over this y-axis, right? Now what happens? How it is looking, right? So if you are taking an odd signal, the reflected version x of t and the odd signal are negative of each other, right? See here, this is the signal and this is exactly opposite to the taken signal, right? So for even signal, the signal and the reflected signal are identical, whereas for the odd signal, the taken signal x of t and its reflected signal are negative to each other.
For more videos, please do like, share, subscribe to our channel. Let us know your suggestions and queries in the comment box. Thank you.